Good afternoon. Mm, So tomorrow test is examination lab 10 to 2. You read about this already? So this is the question. The main question. Normally we use this delta P available plus this time minus P with. So delta P is the different. We have 2 points normally. So depend on you which one is point one and point two. So the delta P is between the point. Delta U same 2 point G represent the height between the point. Then F is for the friction within the pipe. And shaft work over display. And so in simplified form of the mechanical measurement for frictionless process F in term to 0 is to be shaft work. So this equation will generally the P plus the terms will be plus G and exit. If you have any question, just ask. There will be some exercise that you need to do. Basically, tomorrow test is can you see the video? Only different is the part that you need to explain. See the exercise. If yesterday, what flow along to the system shows the effect of the equipment. Estimate the pressure required at point one. Friction versus negation. So point one and two here is the yours. And this one can be one. So, alright. So point one, the ID tip is inside the internal diameter 0.5 second within the pipe. This is friction loss and velocity. So the coverage will be the same. The pressure pass the pressure at point one. The two is 1. So all of the term of the Bernoulli equation 7.7-3 Sorry. Okay. See, only set delta P the variable to be determined and the values which must be calculated from the or derivative of the outlet type. So this equation is equal to u times u. So here we need to find the density. So density we get from mass flow rate. So volume flow rate. This is the unit conversion. This is the A part here. 5 times 25. 25. Okay. Then 2. Insulin need to convert to liters per. And this is for the time, time conversion. You see, if you notice, you want to see the fluoride, because it says no friction loss, then it's the same, except for the yeah, yeah, that is then we calculate. So you 17%, because it's restricted, it's not, if more, realistic. Yeah, it's only 4.24, then you just minus 10 minus 4.1. Let's put and we get it. Yes. Class. Energy later. Repeat it. Yeah. Cleaning. Do it by 20 plus. Yeah, should be. Because this is the U to the power 2, isn't it? You should describe it to
So I have a question.
yeah.
Which means that equation 7.7 3 rearrange kannya apa?
So the full range.
Oh,
Range.
oh no need. Okay.
Yeah, the most important equation is this one.
Oh, now
This
kita
one
pakai 7.73 kan?
is 2. When
Oh,
so if there are no friction, we just cancel kosong. Kosong.
oh,
Kalau data you tak ada kosong. So
Oh.
question penting is 7.7 this 2.
Okay.
Alright. Well, you take to 71 equation. Then you see the equation 7.7 dash 2. Okay. It's okay. Tetapi, so when you choose your point, either which one, 1.1, 1.2, but when you do delta U, delta P, it must be, oh, delta Z in this case as well. It must be Z2, P2, or P1 the time, then minus P1. Nah, stick je. Sikit salah ni negatif. Sebabnya, okey, tidak masuk dalam equation. Okay, delta P is B2 minus B1 euro kg into 2 delta U. You notice this is for delta U2 over 2 is the equation. That one in this bracket, square bracket, is the unit conversion. Pada Newton, when you have gravity, acceleration, z is the height. This is the unit conversion. Not really Newton. Okay. So substitute inside negative 271. 135.5 is one. January. Plus 490. 499.81. Empat sembilan satu ya. 490.5. Itu is use this dulu. Newton per meter square 1.0122.5. Newton per meter square to get kilograms. This banyak ini. Tingkat berapa? Sudah ada. Sudah banyak itu kan. So the answer is 4.56. If the container is drained relatively slow, the kinetic energy at point 1 may be located. This is important. So once, let's say you have to tank, so this tank supply water to the so if this water drain slowly, ada tapi saya tak so maybe your delta U square is equal to what? Because it's minus 0. Now what to when we do this, 10 minutes. So what to do first? First of all, you need to write the equation first. Delta P over rho plus delta U2 over 2 until the end, until WS over M dot is more. Next is to identify the variable. So P, okay, P1 ada is 5. P2 is 9.77. So U1 is 5, U2 is is no U2. How about density? Density, there is no density. It's just specific gravity. So you multiply what with density of water in terms of get the density of the aqueous solution. Log down delta P dah G tulis 9.81 depend dengan unit lah. If it's using British, then you need to use British to 074 second. Delta Z. Delta Z is 6 meter. Sebab delta P equal to P2 minus P1. So P2 di atas now, P1 is 0. So it's negative. Ini yang negatif, it's negatif. Contohnya point 2 is di bawah. So P2 is 0 minus 6 is negative 6. Then F adalah tepi friction. Friction is neglecting friction, reason saya. So ada friction pasal. So delta P ada apa aja? 977 minus 1.5 over 123 1120 plus delta U is boleh cari delta U. So U2 ada U2 saya U2 minus U ada ya power of 2 ya. Lupa power of 2 so meaning 5 sorry U2 minus 5 to the power of 2 divided by 2 plus G 9.81 times Z is 6 equal to 0. Berapa U-nya? Siapa dapat kira dia?
Sekejap lagi kira.
Cepat. Tunjuk jawapan kah? Saya ada jawapan. Tunjuk jawapannya juga. Boleh show screen. Next is if the diameter at point 2 is 6 cm, what is diameter at point 1? Okay. So whenever there are diameter involved, so you need to use the equation V equal to UA. Yeah, at the moment we have V on it. So we don't have V. Yeah? So what we need to do is find the V. Because V for point 1, point 2 is the same, similar because of the neglecting friction. So what you need to do, you equal to V over A, ya. Cari V-nya, V titik ya. U meter per second ya. 5 kan? 5 darab dengan air. Point berapa ni waktu? Point 1. Point 1. Siap. Tak ada meter per second. Ini saya ada. Ini yang saya ada. Meter.
So, yang specific gravity macam ni, so dia convert pergi ke volume ke? Specific gravity.
Dah dengan dia aja. Dah
Oh, ya
dengan specific. Because specific gravity doesn't have any
effect.
unit. But it's normally, bukan normally ya, memang dia akan, it will be relative to density of water. So what you need to do is multiply with density of water. Paling mudah is 1000. So dapatlah density for aqueous solution.
Okay.
So U2, U2 daripada A padahal. Berapa U2? Dia dapat U2, boleh dah cari V. Once you get the V, then you get the A for point 1. Dapatlah cari diameter. Itu apa itu? Ada semua sih untuk. Gwendoline Itu apa? Malaysia kan? Set ya, gambar. Tunjuk. Video je. Sikit. Dapat buat? Ada idea buat macam mana nak cari? So, recap. How to determine velocity at point 2. So first thing you need to do is write the equation 7.7-2. 7.7-3 is Bernoulli. The mechanical energy balance is 7.7-2. Yang ada delta P over rho plus until WS sub over M. Then you identify each of the variable, point 1 and point 2. Satu-satu tulis saja. P1 apa, P2, P1 apa, U2 kosong. Salah. U2 is tanda sampai G berapa, delta Z berapa, F berapa. Yang kosong lah, kita tulis lah. WS yang berapa, kosong. Then what you start to masukkan nilai dalam equation 7.7-2. Buat yang nampak. Dah dapat ya, Alicia? Itu 0.82 lah. Oh, sikit tau. Okay. Jolin mana? Jolin. Then itu is 82 kan? So itu equal to 0.82 liter per second. Saya tahu saya dapat. Saya dapat suaminya kan ya. So from that two you need to you can calculate the V. So you can do equal to V dot of V is normally pipe-nya speed pipe semua beda. So inilah pi R square ya. Pi area itu R. Kira sedikit. Lupa V. V. Kenapa? Heavy material test. Oh, begini ini sih asal. For B we use continuity equation. What? Continuity equation. Tidak. Makanya equal to VA ya. Dia delete. Equation tu. This equation lah. Dia equal to VA. At the moment you have U2, so you need to find B. Because flow rate equation say that the friction losses is negligible. So we can assume that the V is similar at any point of the pipe. So berapa D? Kita view, ya lah, betul lah. Kita view. Berapa je? 2.43. Okey, 2.43 meter cube per second lah. So that 2.43 meter cube per second, as long as you know what to do, betul tak? Betul. So that 2.43, you masuk lagi dalam equation U equal to VA, ya. In this case, you find A1 dah. Because U1 ada 5. So berapa A1? Okay, calculator je. 2.43 divided by 5. Bila ada kelas, senang tulis. Ya, jawapan. 2.43 cm. Thank you. Alright. So, kita tahu. Oh, ya, tahu. So, that U by Gwendolyn, check the chat. 0.82 meter per second is referred to U2, 0.2. And D1 is 2.46. So in order to get the D1, you need to find A1 first. A at 0.1. Once you dapat A, then you use that equation pi r square. Any question? Sebelum kita beralih ke sampel. Okay, sudah. Second example, gasoline. Rock equal to 50 pound mass over feet cube is to be siphoned from a tank. The friction loss in the line is equal to 0.5 pound force per pound mass. Estimate how long it will take to siphon 5 gallons. Neglecting the change in liquid level in the gasoline tank during this process. All boleh lah. Sebab mechanical energy balance ada banyak jenis dan banyak rupa. But the gist is using the 7.7-2 memang dapat punya. Ya, memang dapat. Use the same method yang saya kata tadi. Tulis dari saya satu lagi buat ini. Estimate how long. Okay, sini dah. Neglecting the change in liquid level in the gasoline tank during this process, assuming that for both 0.1 and 0.2 are at 1 atm. So neglecting the liquid. Why it said neglecting the liquid? Because kelasnya berubah tu. Satu lah, makin kurang. But number 2 yang makin banyak lah. Ya, should be neglected lah. So if we neglect these changes, so the data Z is fixed. Alright. So 0.1 di atas, 0.2 di bawah. So Z1 2.5, Z2 is 0. So apa lagi kita dah ni? You see here 0 meaning the U velocity is insignificant. For U1, for U2, yes, it's going out. B, okay, please. See, question list. Buat yang semua ni dah, dia tulis, dia write list, then identify the variable. Ni kosong pun tulis juga. P equal to 0, because 1 minus 1 is 0 in this case. Delta U is equal to U to the power of 2. Sebab delta, sorry, U1 is 0. 0 approximately G in distributed. The second plane. Delta Z is negative, huh? Because Z2 minus Z1. F friction then WS. So in this case, U2 plug in masuk dalam 7.7-2. So U2 over 2, this is unit conversion, 32.174 is the gravity acceleration times delta Z plus friction. Then you get U2 equal to 10.5 feet per second. The volumetric flow rate of the fluid in the tube is equation yang B equal to U times A. 10.5 times this A, we convert to feet per second. This is the volumetric flow rate here. So volume to be drained is 5 gallon. Change the convert the unit to feet cube. 3.1. Ini question. So, akhirnya lah cerita. Take one ya soalan ni ke? Saya jawab Izan. Okay. So, kita cerita. Cloth bag filter I used to remove particulate matter from the gases, passing out from several processes. Boiler stack, large industrial plant, the bag become clogged and must be replaced frequently since they are quite expensive. Rather than being discarded, they are empty, washed and reused. In the washing process, detergent solution with the specific gravity is G, 0.6. So how to get the density? Because Hg is relative to density of water, then you need to multiply with density of water. From a storage tank to machine. Okay, this two storage tank transfer to this is the machine. The liquid effluent from the machine is pumped through a filter to remove dirt. And clean detergent is recycled back to the storage tank. So once it's finished, water goes here, then filtered, then pumped back into the storage tank. The detergent flow from the storage tank to the washing machine by gravity heat at the rate of 600 liters per minute. So from here, transfer to washing machine 600 liters per minute. All pipe in the line, so any pipe in the line including here is 4cm ID. Friction losses negligible in the line from the tank to the washing machine. So from here to here, this line F equals to 0, but line return is friction 72 joule per kg. Just improve the pumping filter. Calculate the value of H. Alright. So about. So first of all, write the equation. So we do for this part first. Yeah. Right, equation 7.7 dash 2. Find all the variable. Copy. Let's see this one. If you assume delta P is 1 at the end for storage tank and 1 at the end for the washing machine, it should be 0. So plus delta U, because this is friction loss, meaning the volumetric flow rate is the same. However, for if the container is being drained relatively slow, definitely at the point maybe liquid. So dia tidak besar ni. Tank atas ya. Yeah. If the tank is very big, which we don't know, we can assume the kinetic is 0, approximately 0. For 0.1, 0.1 di atas system big. So meaning delta U square equal to U2 square minus 0 over 2 plus G negative 1 delta Z Z is what we want to know is equal to 0 if we do for this part. For the whole part, kena ada is what? Is it, yeah. So, baca jawapan. So U equal to 600 liter per minute times divided by 2 Oh ya, CM. Tukar liter to meter cube. Misalnya, itu. Okay. 1000 liter. Satu meter cube. Tukar untuk CM. CM square ya. Square. So 10.000 GM square. Yang satu meter square. Itu 600 divided by jadi 7 meter per minit. Salah. Liter kan. Liter cube. Berapa? Cepat. Oh, cepat lagi dekat depan tu. Ini dapat dengan sama lah. 3 meter lagi. So how you calculate it, Samuel? Can share with the class? So there you go. For staff work is 0.75 WS. Okay. So let's call it. So once you're done with this sebelah tu, tahu ya di sini. Tempat hash tu kan. Ya, hash yang penting. Because then you need to do another one sebelah ya. With the kitchen. Itu pun sama aja tuh. Sensasi. Itu flow from elevated reservoir to a conduit. the turbine at the oven, and out of the turbine to a similar turbine, the point 100 meter above the turbine, the pressure is 207 kilopascal at point 3 meter. Below the turbine, the pressure is 124 atmosphere. It was the calculate the turbine at this the key. So we have pressure T1, T2, the zone to the U. Use it. Check this one. U. Equal to 0 because of the macam sama saya. Similar conduit je. Oh, wow. Because the diameter is the same and no data given for the friction, so they assume 0. So V is the same. So U equal to V over A. A is the same as well. Also the size of the conduit, similar. So meaning U1 and U2 is actually the same value. It's this line yang kosong. So delta P over rho plus G delta Z equal to shut in. So that vector over it plus. So find A. M equal to WS over P over plus T Z. W is equal to megawatt. -1 times 10 to the negative 6 Newton per second. This is conversion for watt. This 10 6 is the meter. Tapi P2 minus P1 negative. Change the unit to 30 over rho. This is water. 1000. X G is negative solution of the one delta Z negative 103. T delta Z conversion. Pak macam itu. Oh, any question from here? Ada. Oh, ini dah. Okay. Just nice. From a reservoir passes then through a third party in discharge from a service in ID5 at a point 55 meters below the reservoir surface. The beam delivers 0.8 megawatt electrical flow rate of water emitted per minute. If friction is neglected, friction included would higher or lower flow rate be required. But the friction will soften this problem is multiple times and solution is then to the second. So first, draw first. Let's coba dulu 5 minutes. If you don't know how to proceed, what you need to do is write the equation first. Delta P over rho until WS. Next is identify all the variable. See the ID pipe. So one using just this reservoir, the bin, then the pipe discharge. So which one is 0.1, 0.2 is up to you. Satu atas ke, dua atas ke. But delta P must be P2 minus P1. Delta U is U2 minus U1. Percent. That's but to attempt to be discharged from a 70 cm ID pipe. So then, okay, maybe it's similar. I think the pipe from them reservoir goes to the turbine to the discharge is 70 cm ID pipe. 70 cm. Okay. So what we have here is P. Do we have P? It's not P. That P. P is it? That P. So meaning P is, we didn't give any value there. So we assume it's the same. So it should be 1 times or 0 plus delta U. So delta U for a similar size pipe with no friction, similar diameter, no friction. So meaning U is 0. So G delta Z to the Z part depend on where you put your pointer to here. Plus F0 equal to WS 0.8 megawatt over M dot. What's that? What is it? equation. So equation will include that higher or lower flow rate will decide. Jika ada X. Ini dah perfect. Kita lah. Oh, tadi situ. This way. Based on the information, it's straightforward lah. So when you include the F, the F letak kat bawah. So if you have F down there, so you need the lower flow rate. Yeah, lower flow rate. The flow rate will be reduced. Faham soalan tu? Equation included with the higher or lower flow rate requirement. So in order to maintain the turbine delivered, meaning you need to have a higher flow rate because of the friction. The friction you solve in certain has difficulty. So it's another. Oh yeah, what is it? Because it doesn't say if the part from the reservoir in the discharge pipe is the same or not. We assume it's not the same. That's why it gives you that 70 cm ID. So meaning will tell you in this case, because the dam is very big. So they'll tell you it is slowly, like, drain slowly, right? Drain slowly, which is zero, U1. So you have delta U2. Basically, okay, perfect. 75 detik ini. Dekat sini saya dapat apa nak? Ada yang dapat 75 cm. 0.8 megawatt vertical project, 34 meter per second. Then what is your FG just calculator? Unit price is meter per kg. Yeah. If you use N equal to WS over G delta Z, is it possible to get answer? If it's 275.5 is the answer. Taking into account the volumetric flow rate is the same. Yeah, because the size of the pipe is the same. If the size of the pipe is not the same, then you need to include delta U. U square over U2 square over 2. But we don't have U, right? So you need to calculate U to be over A. But kan cukup untuk mechanical engineer. For anyone. So, these changes. The next is the ligament and processes involving these changes. For human procedure, when working on a equivalent on the process in which a component exists on two faces, you must choose a reference state for the component by specifying both the face feature and calculated specific entity of the component in all process through the state. If the substance is a liquid, make it reference state. Process through the mesh entropy may be calculated as a sexual effect for E. Then is bring the liquid from the reference temperature to the point at which the mesh P small vaporize the liquid bring the method to the process through the picture and sound. What? That we can just make it three step. It is the general procedure. So you need to have a spin table, property table. Like on the an equivalent liquid mixture of penicillin, then you will see fed continuously to a vessel in which mixture is heated to 30 degrees C. The liquid product is 14% D. Benzene and the product is 68.1% benzene. And the liquid must be transferred to the mixture by very non-acid. So most of the disease of inquiry and partnering is as this is not safe. Then goes to the paper. Let the confirm my benzene. It up for the form my benzene for the third part. Mixture with the so one like the zero point six. Take care of it. It's like this. Energy element on non-reactive processes 2023 part 3. Yeah, that's right. What does that mean? So the term is Lenin. One more with the ND plus NA, so ND is 0.242. So ND and NL refer to this part. And this one is one more. So this one we don't know. Now, yeah, ND is 0.52 more. And more of liquid mixture is 0.648. Kita tunjuk lah. Sebab kemudian the reference-nya ni kita pilih juga. Waiting for the process which is to form up to the level for the process appear as follows. So this table, so we need to run. So here, because it's phase changes, so then you need it. Yeah, sure. Sure, see. And it's only percent. 1% explanation. Benzene vapor, turbine vapor. Yes, will be different. And in mole, this is grounded chakra from the figure. Need to find why it's zero because of the reference the picture, reference condition. And so, yes, so you need to find the enthalpy for the outlet. This is grounded figure. This one is to exchange. So the value of n r, the value of n r from the normal rotation of benzene. Okay, we do not know the fit stream pressure, so we stream the delta H potential from the to prefit, which will be difficult since the process is not running at an unusual low temperature and high pressure. We neglect the effect of pressure on body in the calculation of P1 flow. The pressure can be removed from the entering calculation and transfer with the system to G. If it was to you, then that I needed to declare the critical 10 from the V1 to so the V1 to like this. It will be V1, V2. This is itulah. This is V1. Sorry, there's the HM, there's the vectorization. The HF. Heat of formation. Heat combustion. But heat of formation, heat of combustion, reactive. This is non-reactive. Nothing and vaporization lah. In case because it changes phase, but for your case, it's vaporized. So just actually benzene and toluene. Toluene is best. Yeah, toluene detention. I think toluene. What? So delta HB toluene at TB. TB I refer to aduh, boiling temperature. TB. Boiling point. Eh, aduh. TBC, okay, C. Boiling point. So boiling point at benzene at T. Yeah? So if you increase the temperature from that reference temperature to the boiling temperature, then you get TB is delta HB. Kita tengok balik ya. And twin equation, situ. Baik, before 640. Yeah, yeah. Sure. So H1, benzene liquid. The formula include, okay. So H1 is 10 to 50 degrees C. 10 referred to 50 degrees C. H1. Liquid. Salah. Berubah. 50 degrees C. So CP C6 H6 DT. So CP So apa CP-nya? Mana CP? CP for bensin. Ni ada dua. Satu state lah. Liquid or gas. If it's liquid, you should use the liquid part. So equation wise-nya, then it have a variable A and B only. You see? So take 126.5 times 2 of negative 3. This one is equal to 4 times 10 of negative 10. Untuk tahu macam mana nak pakai CP ada dalam slide sebelumnya. Don't estimate. Do not estimate. Dia jangan makan. Hanya ya. This is example to use CP. You dah belajar siapa? Masih belajar dah tu.
Already, Doctor, since last semester, but we study
Ya,
ourselves.
ada orang lain ya. Nak tahu macam mana nak ambilnya, you need to know how to retrieve the information and put it inside this expression. So this contohnya 0.127 perfect. Ada soalan ke? So this equation from that table. This table. So C6H14 from the door. Check lah. C6H14. Xen kan ni? Xen. Let's see. See. Where is it? Oh, yeah, this is C6. Okay. The one is vapor. Okay, sir. For 133.77, sorry, 137.44 times 10 to the negative 3. Lepas ambil 3 lah, negatif 3. So, negatif 5, negatif 8, negatif 12. Kita kena Indonesia-nya. Dah tanda. Once you, kolpak ni ada. Ada T tu. See here, contohnya form 1, form 2. Form 1, form 2, depend on this column lah. If it's, let's say, equation using this calcium carbide, form 2, so you use this equation. Okay, so the expression is A plus B. Sini datang A dengan B situ, value ya. D plus CT square plus DT cube. So once you get this term, because this is integration, so you need to integrate. Dapat kasih. So ini integrate. Dapat cik lah. 47.1 dapat cik. Ada yang confusing. How to integrate? betul. Pada betul. Buat ChatGPT apa cara? Yeah. So, I tak tahu kan. So, untuk jadi T, this one become T square. Kan ada dua depannya, atas ya, T square.
Yes.
Over two, buat the rest lah. So, that's why H1-nya panjang ceritanya. Gitu. H1 itu. Okay. So, this one, H1, boleh nak aja. Buat term itu. H2 pula, for Thorvin, go to that, uh, go to the table.
Table B1, B2.
Hmm. Dia ni saya dalam
B1,
computer.
sorry.
Dekat V je kelapnya macam. Siapa?
Okay, doctor.
Adam kan dulu. You find the term for this one first. Sini dapat data HB.
Heat of paper station, right, sir? Am I right?
Data HB from table B1. What? B2. Check
B1, yeah, B1.
B1. B1. You see the picture there? Yeah, because we want to. Because why we need the temperature? Because there's a change in change in
The phase changes by phase.
yes, phase changes. Betul. Phase changes. But yeah lah, jadi semua. How about this term? When you get this term,
B1, doctor. You go to PB first, doctor. Wait, where was I?
table yang ada A plus BT plus C.
Between HM and HB, 30.765.
Oh, kira-kira dah. Terus. Any more question? Soalan? Faham tak? So
Yes, we
whenever there's
understand.
whenever there's a phase changes, you need to raise the temperature to that phase changes. Phase changes to that boiling temperature. Why you need to elevate it to that temperature? Because of this physical property data, because they are limited to TB. You see here, benzene it's 80.1.
B1.
HV come from where? HV come from table B1. Benzene is 30.765 kg per mole. So this one is once you elevate
Doctor,
it at temperature, you need to reduce it again. Because why? Because your question is at 50 degrees C, the outlet not 80 degrees C. So 80 goes to 50. Yeah, so
80
this
is
is
the boiling point,
CP.
right?
Yes, Samuel. Apa soalan?
80.1 is the boiling point, right?
Yeah, 80.1 is my point. This is for benzene, this is for toluene.
This
See,
question require
yeah. So once you have this value H1 until H4, you plug in again into that table, complete kan ya? Then calculate what? The Q equal to delta H. So meaning equal to N. Jangan lupa dah M lah, N lah. N ada depan tu. Ya, N mol lah. N darab H lah. Lagi soalan tu. Integrate 50 to 80 or 80.1 to 50. Dah tulis dah siap. 50 tolak ya lah. Atas tolak ke bawah. Suggestion lah. You do this lah. Berapa minit? 10 minit cukup. A liquid stream containing 50 mole benzene and the valent toluene. So valent is 50 lah. 15.5 degrees C, which is here. The continuous single stage evaporator at the rate of 1320 mole per second. Lebih kurang ya salah. Cuma unitnya in mole per second. Oh yeah. This is mole per mole. The liquid in vapor state leaving the vapor above at 95 degrees C. The liquid contain 42.5 ke bawah kan? So 42.5 is benzene, so tolak dengan 100 saya dapat toluene. The vapor part 73.5 benzene. So the remaining is the toluene.
the answer is 2.42. times 10 to the power 4 kilowatt.
Oh, jawapan tak kah?
Yes.
Oh,
Either
tepat juga.
2.41 or 2.42.
Okay, good ada jawapan. So the first thing you need to do is do that valence first, this valence. So you determine this valence.
On
NV and L. Right.
NV is 319 and NL is 1000 watt.
Okay. Once you get that metal valence, you do the table. So you choose the reference. The easiest way to choose the reference is to choose the reference for the inlet. So once you choose that inlet as the reference point, you need 35 degrees C, like this. 30 degrees C liquid, and like that, 1 atm. So automatically the H for inlet is 0 lah. So what we need to calculate is H1 and H4 lah for this. Similar lah to this. Benzene and toluene as well. Both have vapor and liquid phase. So start with H1, which is maybe you start with benzene liquid first. So H1 is like this. So instead of the 10 is 25 goes to 95 in liquid form. So in liquid form, there is no changes now. Tak ada apa. Phase changes tak ada. So straightforward. Where to get the table? Table B4.
Okay, B2 or B4.
Ada cari table. Table B1. B4. Yang pula. Di Jawa sebab ada state table. Beda. Itu saya CP. Yes. So H1, H2 is if you follow this model lah, liquid first, then vapor. So meaning H1, H2 is senang lah. Just cari that value over that table B2. But for the vapor part, so for the vapor part, meaning there are phase changes because your reference point is liquid. You see? So, but the substance for this row is vapor, so there are phase changes. So you refer to this. Instead of 10 is 25. 25 goes to the boiling point of that component lah. Whatever is it. Benzene ke, toluene, ethanol ke. Yeah.
Okay.
Then until the temperature, then you need to either reduce or increase to the targeted temperature of 95 degrees C. Ini, ya 95. Lupa atau pendek, tapi bila you dah buat lah, cuba you start exercise malam pula. Jam. possibility nak buat silap untuk integrationnya memang mudah lah. Sebab bila kita substitute value 50 minus, so this case, this is 50 minus 80, not 80 minus 50. Dia pun dah panjang juga, so cukup atas. Any question? That's all itu. This boleh buat. Yeah. So after
Yeah,
mid-sem kita bagi give you the
assignment.
maybe this week lah bagi assignment.
Only one assignment, right?
Only one kah?
Doctor cakap yeah, in the
Saya
first day,
tengok-
doctor give.
Saya tengok course plan dulu.
Okay.
Buat decide apa lagi. Cuma part aspirant tak ada lah.
Doctor got one
Yes.
essay.
Any more question?
Ada soal
So-
essay ka?
Apa?
Essay.
Essay. Ya, essay.
Wow.
Cuma soalannya macam yang dalam elite ya. Saya semua macam ni lah.
Yeah.
Say something else. Okay. Apa sih ya? Okay. Dia kurang lah. Lupa soalannya contoh ya. So the part with the rubric is this one. Examine the condition of the system and get the impact on the final result. So contoh soal profile. This is for the mechanical. AC part is this one. Yeah. But AC part is only 1%. Kurang bukan 1%. 1 mark. 1 mark.
One more is enough lah, doctor.
But
One mark is enough.
ramai dah.
So,
Any question?
mesti 10.30 kan sebab saya ada test pukul 11 sebenarnya.
Hah?
Oh, test elektif.
Tes apa?
Test elektif.
Oh, you the test.
Oh,
Kita
menawalkan pun boleh. Sekejap saya.
makan pukul 9.
Oh, boleh sekejap lah. Tapi saya tahu yang lain lah.
Ada yang ada kelas saya silap. Saya kurangkan delaynya 30 minit.
Sejam 1 hour sekejapkan this test.
Sejam je.
Okay.
1 hour je. Bila you kelas tu pukul 11 lah. Duduk kelas kan. Ini sebenarnya. Berapa orang yang ada kelas? So that is lah. And then oh. So what? Okay. Ini lah. We have exam at 12 p.m. Alright, so how about any more question? So tak ada question lah. So all the best. Thank you. See you tomorrow.
Thank you, thank you, Doctor.
Okay.
Okay, Doctor.
Mm.